Hello friends, today we are going to see the next part of micro manufacturing technology, unit 6 of manufacturing process 3. In the previous lecture we have learnt about the bulk micro machining, surface micro machining. But today we are going to see high aspect ratio micro machining, particularly the LIGA manufacturing process. Now we'll see what is meant by LIGA. So LIGA stands for lithography, galvanoforming, F-forming. This is the name of, or it is the long form of LIGA, lithography, galvanoforming, F-forming, which is an important tooling and replication method for high aspect ratio microstructures. So this technique uses X-ray synchrotron radiation to expose thick acrylic resist of PMMA under a lithographic mask. So in this technique, this lithographic PMMA, which is under lithographic mask, is exposed to the X-ray radiations, and the exposed areas are dissolved chemically, and in areas where metal is removed, metal is electroformed, thereby defining the tool insert for succeeding molding step. Now this LIGA is capable of creating very finely defined microstructure up to 1000 mm high. Now this is the process. We will see in detail, step by step, how this process takes place. So the MEMS micro machining process known as LIGA uses following three fabrication process steps. Now LIGA, as I told you earlier, is a German acronym for lithography, that means lithography, galvanoforming means electroplating, and F-forming is for molding. So LIGA stands for lithography, galvanoforming, F-forming, or lithography, electroplating, molding. So this LIGA fabrication is used to create high aspect ratio structure through the use of X-rays, which are produced by synchrotron, or relatively low aspect ratio structures through the use of ultraviolet light. So for high aspect ratio, X-ray produced by synchrotron are used, and for low aspect ratio, UV light is used. So LIGA, once again I am telling you, it stands for, or the German acronym for lithography, galvanoforming, F-forming, which is lithography is lithography, galvanoforming, electroplating, and F-forming, molding. Now how this LIGA process takes place? These are the following steps for the LIGA process. First of all, a very thick, which is up to 100 of microns, resist layer of polymethyl methacrylate, that is PMMA, polymethyl methacrylate, which is known as PMMA, which is a resist which is deposited on the primary substrate. Substrate is the primary one on which this PMMA resist layer is deposited. Now this PMMA layer is exposed to collimated X-rays, and then it is developed. First of all, there is a primary substrate on which PMMA resist is deposited. This PMMA layer, which is deposited on the primary substrate, is exposed to collimated X-rays, and then it is developed. Metal is electro-deposited on the primary substrate, and then PMMA is removed or striped out, resulting in freestanding metal structure. A plastic injection molding takes place. This is how this process goes on. First of all, there is a deposition of resist layer, which is PMMA, polymethyl methacrylate, which is PMMA, is deposited on the primary substrate. Then that PMMA is exposed to collimated X-rays and then developed. Then electroforming is done, that is metal is electro-deposited onto the primary substrate. Then that PMMA is removed, resulting into freestanding metal structure. Plastic injection molding takes place. So this LIGA fabrication process is composed of following steps. First of all is the exposure. Second one is the development. Third one is electroforming. Fourth one is striping. And fifth one is the replication. That's why here it is saying that it is an important tooling and replication method. That's why here it is exposure, development, electroforming, stripping and replication. This is how the LIGA fabrication process goes on. Now in this first step, you can see over here, this is the substrate on which PMMA is deposited. The coat thick photoresist, that is PMMA 300 to 500 on a substrate with an electrically conductive surface. Now the second step is there is a X-ray radiations. So X-ray lithography with extended exposure from highly collimated X radiation to penetrate thick resist with well-defined sidewalls. So the X-rays, they have to penetrate through this thick layer of PMMA. That means irradiation involves exposing a thick layer of resist to high energy beam of X-rays from a synchrotron. The mask membrane is normally a low atomic number material such as a diamond, beryllium or thin membranes of a higher atomic number material such as silicon or silicon carbide. That is the mask which is having either low atomic number or a high atomic number. Low atomic number such as diamond or beryllium, or higher atomic number silicon or silicon carbide. The first step is coating of the substrate with the thick layer of PMMA material which is called as photoresist. Then second one is exposing that PMMA to X-ray lithography to penetrate through the thin with well-defined sidewalls. Third step is the development. So in this step, the pattern is etched into resist substrate by the use of X-rays and desired structure is formed. So this structure is required. So in this how development is done. And next one is the electroforming. Electroforming is same as electroplating. So metal electroplated on the exposed conductive substrate surface. So electroforming suggests that the plating is used to create an actual metal component. This is actual metal component. That's why the next step is the electroplatings. Third one is the development. Development means desired structures formation, and electroforming is the plating is used to create an actual metal component. And the next one is after photoresist removal, metal structure formed may be used as mold. Now this you can use as a mold for making different jobs. So separate metal. So this is the requirement, and this is how this is prepared by using LIGA process. Now once again we will see in tandem. This is first the substrate. This is the PMMA which is exposed to X-ray radiation. After that there is a development, then electroplating, and this is the separated from PMMA. So this is the final product. Now what are the components of the LIGA process? Masks. Masks are composed of transparent low atomic member carrier, a pattern high atomic number absorber, and a metallic ring for alignment and heat removal. So masks, they are transparent, low atomic number carrier, patterned high atomic number absorber, and metallic ring. These carriers are fabricated from the materials with high thermal conductivity to reduce the thermal gradient. For example, vitreous carbon and graphite, silicon nitride, titanium. Masks can be of different types. One is mask created by electron beam lithography. Thickness is mentioned over there. Plated photomask or direct photomask. In this, there are the different types. The mask can be used either may be created by electron beam lithography, which you have already studied in rapid prototyping. Then plated photo mask. Then third one is the direct photo mask, which provides 80 micrometer thickness. Substrate. As we have seen earlier, the starting material is a flat substrate. such as silicon vapor or polished disc of beryllium, copper, titanium and other material. The substrate is electrically conductive. And the photoresist. For fabrication of high aspect ratio structures, photoresist is the must. It forms a mold. Photoresist forms a mold with vertical sidewalls and must be free from stress. The use of photoresist depends on types of LIGA processes used. For X-ray, PMMA, that is polymethyl methyl carbonate. For UV rays, SU8 is used. The photoresist with higher molecular weight is applied to the substrate by glue down process. So these are the different components of the LIGA process. First is the mask. These are the transparent one. Then mask can be of different types, that is either made by electron beam or plated photomask or direct photomask. Substrate, as you know, which is a flat substrate such as silicon vapor or maybe of different materials, and that should be electrically conductive. And the photoresist for fabrication of HIR structures, that is high aspect ratio structures, photoresist is the must. And for X-rays, you can go for PMMA. For UV, ultraviolet, you can go for SU8. So friends, we will see one video on this. See this LIGA micromachining process overview. First of all, there is a substrate and on which there is the application of PMMA. Then there is a lithography mask which is used and which is exposed. After exposing, you can see the collimated synchrotron radiation, where after this there is a process of development, that is developing. Here you can see the developing. Then afterwards it is the electroforming process, and after that chemical mechanical polishing is done, as you are seeing over here. This is the chemical mechanical polishing, and after that there is a removal of PMMA, and that is called as the releasing of PMMA. Now you see here LIGA process recurs. This is how LIGA works. Thank you.